Welcome back to the classroom. My name is Mr. Wong. We are going to go through the Module 2 Inquiry Question 3, explain the exam of the 2019 Independent Physics paper, Question 19 for the Year 11 syllabus. We have a 1.6 kg fish that is moving at 0.2 meters per second in this direction. We're going to make that the positive direction. Whenever we're looking at velocity, just make sure you have specific direction. It appears to collide with a smaller fish of this particular mass. So we'll call this mass 1, call this initial velocity 1. This is mass 2, and then it's going in this direction. We're going to call it velocity 2, but because it's going in the opposite direction, we got to make this a negative value when they are moving like so. At the end of it, the big fish has swallowed the little fish, so we're going to have a mass that composes the big fish and the small fish. And it's going to have a new final velocity. We'll call it v3. Why v3? Because, you know, it's a nice number to make. So, looking at the question, it says calculate the speed of the large fish after swallowing the smaller fish. We're looking at the conservation of momentum. So we're saying that the amount of momentum the two fishes had before their collision would be equal to the total momentum they have after they have collided. It's kind of weird to say they collide because one swallowed the other, but you get my point. So, writing the equation along, we have m1 u1 plus m2 u2 equals to m1 plus 2, just so people remember it's these two added together, and then we have the v3. So write the numbers out. Okay, now that I've written it out, all you have to do is just rearrange the equation to make v3 the subject of the equation. And don't forget the value of u2 is a negative value because it's going in the opposite direction, which means it's a subtraction overall. And so you get this value here. So let's plug it into our calculator, see what value we get, and then we'll round off to about 3 sig figs. So the overall value is now 1.66. If we round off to about 3 sig figures, meters per second going in that direction. Okay, so that's done. What impulse does the small fish apply to the larger fish? So we want to see the impulse that the larger fish experiences on its collision. Now, impulse is the same thing as saying the change in momentum. So we can write it as, so momentum, change in momentum is mass times change in velocity. So we can rewrite this as so. In this case, the mass we're dealing with is the larger fish, which is 1.6 kg. And because we're focusing only on the larger fish, we don't have to add the mass of the smaller fish upon that collision. So 1.6. Okay, so let's see what the impulse is. Before I do that, let's just make sure we wrote the correct velocity. 0.2, not 2. Okay, and then we get the value of negative 0.0544. If you have a look at the units we have here, it's kg meters per second. Another way you can measure impulse is actually by the formula of force times change in time. So you can write it as Newton seconds. Make sure you space them out just to represent that. Now, this is negative, so what does that imply? Well, if you have a look here, this value we had here was positive, so we're saying it's going to the right. In this case, it's the same thing as saying it's 0.0544 Newton seconds going to the left. And that's how you do this question about conservation of momentum and impulse. If you enjoyed this video, give it a like to support for more upcoming videos, and I will see you next time.